Okay, so what we're going to talk about is the law of conservation of mass, which means if you get a reaction, whether it's a physical change or a chemical change, and it takes place, the weight that you start with, you'll end up with that same weight after the reaction occurs. So it's called the law of conservation of mass. And it's never been disproven. You can do a reaction and weigh all your reactants, put them together, weigh your products, and they'll weigh the same. So we're going to kind of use that process on here. The first thing is you guys will have to be able to draw these compounds out. So we did some drawing of compounds before. So I'll do this first one. And so to draw it out, what I'm going to do is I'm going to go ahead and put the symbols inside the circles that represents that atom. So this first one is all together, AgClO3. So I'm going to draw a circle, and then I'm going to put Ag there. And then what I'm going to do is I'm going to put another one around at Cl, and then I'm going to put 3 O's around. So that's AgClO3. All right, and it doesn't really matter how you put it in there, just to represent. That's the Cl part. I better make that a little bit more evident. So you guys do the same thing. Okay, you guys do your.
Is it always going to be like the first one that's the biggest?
It doesn't matter how the size that you make them, because right now you just don't know their relative size related to one another. All we're doing is we're just keeping track of our atoms by drawing them out. So it doesn't really matter the size of the circles, as long as you're putting them all together. So then what happens, we get a reaction, and then what we'll do is we'll draw the Ag, similar size, okay, and then we'll put a Cl off of it, like that, okay, and then we'll do 2 O's together. You guys have that so far? Yep.
Is there a reason that you started with 3 O's, but then on your
right? So this is the process of making sure our counts on each side are the same. They're not right now.
No.
So that means we're going to have to change one side or the other to manipulate it so that we have the same number of elements on both sides. Okay? So the first thing we're going to do, we're just going to keep drawing our compounds until they're equal number of atoms on the left and the right side. So first thing is Ag, there's 1 Ag here. Okay, I'm going to just go ahead and stipulate it. You got a 1 Ag there, and you got 1 there, and you got a Cl here, and you got a Cl over there. And you got you guys don't have to do this. I'm just doing it to kind of show you. You got oxygen there, oxygen there, oxygen here, oxygen there. So what happens, we've got an oxygen that is left out of the process, and you can't leave any atoms. We got to show that going somewhere. But the problem is it has to go as an O2. So what do you think we should do to, which one should we draw? So when we draw these out, we have to draw them out just like they're drawn out here. So which one do you think we need to draw an extra one of? Which one?
Oxygen.
Okay, so buddy said oxygen. So we'll draw another oxygen here. Okay, so it takes care of this one here. All right. So, but now on the right side we got an extra oxygen.
So you add one more to the other side.
So, but we have to draw it exactly like this one's drawn. So then we'll draw another one just exactly like that down here. So that's why I left you guys a little bit more room when you do these. Okay? So we'll take care of that oxygen. So here's an oxygen. We take care of one of those. All right.
So then you need another AgCl on the right side plus another oxygen.
Okay. So he's kind of got it figured out. He's kind of seeing what we need to do to improve our situation. So we'll do it just one at a time. So we'll go ahead and we see we have an AgCl on the left side here. All right, we got an AgCl here and here. So we're just going to go ahead and draw another AgCl over there. So I probably don't need to put that extra arrow. I'm not going to do that because I think that's going to be confusing to do that. You'll think that's a separate one to do. So we're going to draw another Ag here. And a Cl here. So then that takes care of the AgCl. And then what do we need to do? Another oxygen. Okay? So then we do another oxygen. Now, guys, we'll simplify this in a little bit. But for right now, it's nice to kind of see kind of where all these things are located. And the reason why. So there's those two. So we should be even. So how many oxygens do we have on the left side? Total.
6.
6. Okay? We got 1, 2, 3. That's not 1. 3, 4, 5, 6. Again, you guys don't have to show this because I'm just being super detailed, showing you that. And then over here we got 1, 2, 3, 4, 5, 6. All right, and in AgCl we've got 2 Ags and 2 chlorines, and so that matches up. So then what I'm going to do is up here I'm going to put numbers in front of these. We call these coefficients. And we're going to put numbers in front of the AgCl3. So how many AgCl3s do I have on the left side?
2.
2. How many AgCls do we have on the right side?
2.
And how many oxygens?
6.
We got 6, but how many oxygen molecules?
3.
So how many of these oxygen molecules?
2.
We have 3. Right? We have 3 drawings of oxygen.
So it's just like the Lego thingy that we did last time.
Yeah, real similar. We could do the same, something similar to Legos and that too with this if we wanted to.
So is this what, like, when it says, like, 2A, whatever, blah, 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 is that what this is meaning?
Yes. So when we had some with numbers in front, I needed to put those in front so later on you can kind of maybe see what they mean. So, oxygen, this is the oxygen we breathe, okay? And that oxygen is actually a molecule of oxygen we're breathing in. We call this particular element O2 is diatomic. You guys don't have to write that down now, but you'll hear me talk about a diatomic molecule. In a diatomic molecule, there are 7 diatomic molecules. All right? Later on, it's important for you to know it, but for right now, you won't. Hydrogen's diatomic, and nitrogen's diatomic, fluorine, chlorine, bromine, and iodine. But you'll see that again. Okay, so this is kind of knowledge that will be beneficial later on when we have to use it. What does that mean that they're diatomic? It means that it's kind of like pairs of shoes in your closet. Right? I mean, if you go search for one, you got to find the other so you can put them on. Okay? Pieces of clothing aren't that way. Shirts are individual, one of them. Socks would be like diatomic, wouldn't they? You got a pair of socks, you know. A pair of gloves you got to put in there. If you go skiing, pair of skis, you need to put 2 skis on. I guess you could do 1 ski, but
Slalom ski.
that would be really, really tough. So this is what I'd like you to attempt to do on this second one. I would like you just to do your drawings. So just go ahead and draw 1 of each. I'm going to give you a minute to do that. So draw 1 of each of those. My drawing for the angles and how they work on angles might be a little different than you, but when you draw these, I think we did this earlier this year, you try to do your drawing to where you have equal spacing on your outside elements.
Yeah.
So if you can have equal spacing on these outside elements here, like these, try to keep them as far away as possible. That's what we want you to do. Okay? All right. So the object for you to do is to draw extra ones like we just did, and then try to balance them out by doing your drawings. Okay? So, which one do you think we need more of? And on which side?
HF
On
the left side,
Yeah.
and then
Okay,
H.
so just wait a second. So what are you trying to get more of by putting HF on the left side? What's that?
I need 1 more hydrogen and 3 more fluorines.
Okay. So which one do you want to try to equal out? The fluorine or the hydrogen?
Let's do the
fluorine.
Yep, do the fluorine. So go ahead and draw your extra ones on the left side. Okay? So go ahead and do that. And you guys just draw until there's equal symbols on both sides. Equal individual symbols on both sides. And you gotta make sure you draw the exact same structure every single time. If you don't draw the same structure, then it's not the same formula. So make sure you do that. How you guys have drawn these out and see if they work. So a lot of, when we first looked at this, these F's, there were 4 of them, and so we've got to show 4 on the left side. So what we're going to do is we're going to draw 3 more of these HFs. Okay, now we have 1, 2, 3, 4. So we've got those 4 match up. But now we have 4 H's. 1, 2, 3, 4. So what do we have to do on the right side?
You need to
Put another
H2O.
H2O. Okay, so now that we've done that, our H's, there's 4 of those, and then we've got 4 on the left. So they equal out. How about our oxygens? We've got 1 and 2, and over here I've got 1 and 2.
Yeah. And then your SIs will count.
So everything counts up right, correct? There's SI. So then what you do is you say 4, 4. We don't put a number in front of this. We can. If you want to put a 1 there, you can. But if you don't put a 1 there, it stands for 1 because it's written out. And then here we'll put 1. And then there we'll put 2. Okay, so we don't want to draw these out all the time. It is very painful for me too. For me, it's painful. A lot of you guys like it. But you're going to have to get to the point where you're not going to draw them out anymore. So what this is doing, ultimately doing, is that you're showing the conservation of atoms, which if you have the same number of atoms on the left and the right, what do you know about their weights on the left and the right? They're equal. Okay? So when we count and make them equal, then we know our weight equals. So on this one, I'm going to do it a little differently, okay? So on this one, what I'm going to do is I'm going to list every element down below. So I'm going to go AL, ZN, Cl. Then on the other side, I'm listing it in the same order, so it's right across from the other one. So I'm going to write same order, Al, Zn, Cl. Okay. So you guys do that. Now what I want you guys is write how many you have of each in there. So now, instead of drawing, what you're going to do is you're going to count, like you already know how to count. You already know how to count them. So just count them out. So on the left side you've got 1, 1, 2, and on the right side what do you have? 1, 1, 3. Okay, so what will happen a lot of times, you'll get an even and odd count, 2 and 3. So if you get an even and odd count, what you have to do is you have to make them both even. So no matter what you have, 90% of the time, if you got an even and odd count, then you have to make them an even count. And you have to find a common number that if you multiply them out, that you're going to get, you know, the right number where they balance out. So this 2, what do I have to multiply that by? And what do I have to multiply the 3 by to get a number where they cancel out?
The 2 has to be multiplied by 3 to get 6. And the 3 has to
Okay,
be multiplied
so
by 2.
this has to do kind of like what we did charges. So what you're going to do, this is what we're going to do first. Okay? We're going to go ahead and put a 3. Now watch. If I have to multiply that by 3, I'm going to put a 3 in front of this. So how does that change your chlorines? So how many chlorines do we have? 6. So I'm going to cross it out. I'm going to write 6. What else does that change? The zinc. So I'm going to have 3. So then on the right side, what do I have to put in front of AlCl3 to get 6 chlorines? 2. So that 2 multiplies by the 3, and so I get 6. And how many aluminums do I have? 2. Okay? I used to do this where I'd show the multiplication, and I don't like doing that because I think it can get really confusing. So I'll put a number like 3 in front of ZnCl3 to balance out my chlorines to get it to 6. And then I'll do the same with AlCl3.
So they end up being 2, 3, 6.
So now, if we look at our situation, now we can kind of look at these other ones to see if we can balance them. So, what are we going to have to do with Al on the left side?
2.
Put a 2 in front of that, and what does that make aluminums?
2.
2. And then, on the right side, what do we have to get?
It's going to be 3.
Yeah, so this is 3 here, this is 1, so I'm going to have to put a 3 in front of that one, and that makes it 3. So it's 2, 3, 6. So that's how you'd balance that one. Okay? This next one. We're going to keep our polyatomic ions together. So this is called a polyatomic ion. It's on your sheet. If you don't know how to identify it, you can look on your chart of ions. And we'll keep, if it appears the same way on both sides, we're going to keep it together. We're not going to separate it in S and O separately. So what we're going to do is we're going to put Ba, Cl, Na, and SO4. Okay, and I might put it in parentheses so that maybe we can kind of look at that whole thing together. And then on the other side, I'm going to put it in the same order. Ba, Cl, Na, and SO4. Now, you guys go ahead and do your counts. And we'll see what you guys have for your counts. So, it goes 1, 2, 2, 1. Is that right?
Yep.
Some students like to put 4.
Oh, I put 4.
Okay, some people like to take that thing and put 4. That's 4 oxygens, but you only have one of these.
I put SO, I mean S and the O.
Yeah, SO4, keep it together because it's identical on both sides. Okay? So keep it all together. Then on this side, we're going to have one of each. 1, 1, 1, 1. So right away you guys know which one you have to change, right? Which one?
CL and NA.
Yeah, NaCl. So how am I going to get both the Na and Cl to equal the left side here? Put a 2 in front of that. You get 2 and 2. Then the numbers match up. When the numbers match up, you're done. So that's all you have to do to balance that one. You guys don't have to put numbers in front of those that where you have them just listed as 1, but if you want to do that, I have no problem with that. Okay? We've done that one already. Why don't you try the next one? The next one's a little bit more difficult. So go ahead and do 5. Leave the NO3 together
AOH.
and the OH together. Don't separate them. And you kind of know which ones should stay together because they're in parentheses. So a lot of times the ones that stay together are on parentheses when you're counting them. So keep those together that are in parentheses. And make sure you're putting them in the same order. I mess up sometimes and I don't put them in the same order. You need to put them in the same order so they're straight across from one another. If you need to finish your test, I thought we'd have some time today and we're not. You guys need to come in. If you guys don't come in by tomorrow, I'm going to keep you. You can come in Wednesday after school and finish it. Okay? But you need to come in, give yourself about 10 minutes of extra time. I'm not going to give you much more than 10 minutes. Okay? But you need to come in and finish that. Is that what you guys have for counts?
Yeah.
So how do you know when to the NO3? How do you know that they need to be in quotations and it's not just 3? Like the top one, like SO4.
Right. So you got a chart sheet you can pull out at any time, and on that chart sheet you'll see SO4 listed.
Okay.
They'll have it listed. Okay. So if you got questions on that. All right. So you guys go ahead and balance it, and I'll see if you got the right answer. You go ahead and balance it. And if you got that one balanced, go ahead and do number 6 on your own. What number do I need to put in front of this NO3 over here?
3.
I need to put a 3. When I put a 3 there, it changes the Na to 3, and it changes the NO3 to 3. So it triples everything that you put it in front of. Okay? So on the left side, I notice here I've got 3 of these, And over here, I've got one of each. So what do I need to do in front of that one?
Take 3 over on the left side.
Yep, I got to put a 3 here. When I put a 3 there, that changes it to 3 and 3, and it's balanced. So it's 1, 3, 3, 1. Okay? So for tomorrow, I'm going to ask you to do 6, and then the 2 on the back.
There's 4 on the back.
Or 4 on the back. Okay? So you've got 5 to do.
Okay.
So I'm going to have you guys balance those.